Hello, and welcome to the BYU Family History webinar series. I'm Marin, and I'll be the host for this webinar. Make sure that your microphones and web cameras are disabled during the presentation to provide a smooth webinar. Our upcoming webinars are on August 1st. With Catherine Grant. She'll be giving a presentation on the Family Tree website, the Family Search Family Tree website, and the mobile app, a comparison between those two. And then on the 8th, we'll have another webinar with James Tanner. He's doing a webinar on the history of the development of genealogical DNA. So that webinar will be on the history of DNA rather than specifics of DNA. As for today's webinar, we'll have Sarah presenting on DNA, so you can get your DNA information from today's webinar. If you would like to access a previous webinar, please visit our webinar index on our website or search on our YouTube channel. All of our webinars are recorded and uploaded the following Monday for your convenience. We also post links to the recordings and other updates on our Facebook and Twitter accounts. During the webinar, if you have any technical difficulties, please use the chat box and I can address your concerns. You're welcome to use the chat box during the webinar if you have any comments or insights. However, all questions will be answered at the end of the presentation. For today's webinar, we're pleased to hear from Sarah Stoddard, who will be giving a presentation on autosomal DNA. Sarah Stoddard graduated from Brigham Young University in 2009 with a degree in family history. She's done professional research for several companies since then. She specializes in German and general U.S. research. She also currently serves as a service missionary here at the BYU Family History Library on the Sunday shift. She's the mother of 2 kids, and she and her husband met while both working here at the Family History Center at the library. The Stoddards live in Orem and are both passionate about family history. Sarah's interest in family history started in childhood when she loved hearing stories from older relatives. Her interest in DNA also started in childhood when she realized she was the only left-handed, red-headed, glasses-wearing person in her immediate family, and she got curious about where those traits came from. When DNA testing became widely available about 6 years ago, Sarah quickly had herself and all of her 4 grandparents tested. Since then, she's turned up surprise cousins for a couple of her grandparents and has zeroed in on the family of a previously unidentified second great-grandfather. She loves a good puzzle and has used her training as a family history researcher, plus her understanding of DNA testing to help numerous adoptees and others solve elusive family mysteries. And if Sarah's ready, we'll turn the time over to her. If you could just wait one moment while I get that presentation set up, that would be appreciated.
Hi, I'm glad to be here. As Marin said in the introduction, I've had a lot of opportunities to learn about DNA and teach others about DNA testing, whether it's in genealogy classes or one-on-one with people I've helped at the BYU library or elsewhere. And one of the things I've realized as I've been helping and teaching people is that many people, even experienced genealogists that I've helped, have some knowledge gaps about DNA and DNA testing and how all that works. I've actually been surprised by how many family history researchers I know that have even themselves tested or had a family member tested, but they still don't quite understand what they have with their results and what they can do with them. So I'm hoping this presentation and others in the future will be helpful to fill in some of these knowledge gaps that people tend to have about DNA research. And I'd also love to answer questions at the end if there's anything I don't address in this presentation. During this webinar, I'll mostly be talking about what's called autosomal DNA testing, but I'll talk a little bit about some other types of DNA testing as well. So in order to talk about what DNA testing is, you first need to understand what DNA is. So that's kind of our first question of the 4 questions that are part of the title of this presentation is, what is DNA? I'm not going to be super scientific here, but there's some basic facts that are important to understand about human DNA for you to be able to understand what a DNA test is actually measuring. And that's sort of our, second part of the what is a DNA test? Then there's also details about how a test works and how you take a test that are good to know, especially if you haven't done this before. It's also important to understand your reason why. Why would you test in the first place? What are you hoping to learn? And who should take a test? Is it useful for you to test? Is it more useful for someone else in your family to take a particular test? So we'll try to address all those questions in my presentation. So the previous slide kind of had a silly picture of a bunch of family members and some animals as well. But there is a point to that picture, which is that all living things have DNA. Even some viruses have DNA. And by living things, anything from, a small virus, a insect, a fruit, a person, all of us have DNA. And I'm not going to be real scientific here again, but the basic concept of DNA is pretty simple. It's the instructions inside of a living thing that tells that living thing how to develop, function, grow, and reproduce. If you're a computer programmer type, we could also simply call it your code. It's the instructions that make you you. Each letter used for DNA code, which the 4 letters are A, G, C, and T, each letter stands for a different nucleic acid. And these 4 nucleic acids are basically ways to make the instructions so your body knows what to do. And you can use these 4 acids to make the instructions for anything from how to grow an ear, how to circulate blood, what color your hair is. And some of these things even change over time because they have to do with the aging process. So getting facial hair, your hair growing gray, or even losing your hair, all of that's in your DNA. Not only do all organisms have DNA, but all life on Earth is actually very similar genetically. 60% of your DNA is identical to a banana. If you move up to more similar organisms, so primates in the animal kingdom, 99% of your DNA is identical to a chimpanzee. 99.9% of your DNA is identical to all other humans on the Earth. So that's all pretty amazing, but if we're also similar, even, me and a banana are similar, what does our DNA actually tell us about what's unique about us and what's unique about our families? DNA tests can answer some of these questions because they focus on that 0.1% of genes that can vary between different humans. There are 3 main types of tests out there that measure unique DNA. There's some companies where you can get more than one of these done, some where you can only do one, which we'll talk about a little bit later when I discuss testing companies. Of the 3 types, Y-DNA and mtDNA, which are listed first, they change slowly over the generations, whereas autosomal, which is our main topic today, changes quickly over generations. Y-DNA testing checks for unique markers on the Y chromosome. Only males have a Y chromosome, and they get it from their father, so that kind of DNA testing is useful for surname research, which will be a topic of an entirely different webinar in the future. mtDNA testing actually measures unique markers on your mitochondria. Your mitochondria is a part of all of your cells that helps produce energy. It actually has its own unique DNA. You only get mitochondrial DNA from your mother. Only a woman can pass it on to her children. So in the picture I have there, the lower picture, all 3 of those people, if it was a grandmother, her daughter, and her 2 children, they would all have the same mitochondrial DNA, but only the granddaughter would be able to pass it on. The grandson would not pass that on to his children. That kind of DNA, because it changes slowly and because it's associated with the female line, really the main use for it in DNA research or family history research is just to rule out a relationship on that maternal line. And then we have our 3rd type, which is autosomal DNA testing, which is our main subject here. Autosomal DNA testing gets its name from your autosomes, which is every one of your 23 chromosomes except your sex chromosomes, except your X and Y chromosome. And so autosomal DNA testing is looking for unique markers and unique segments on all 22 of those other chromosomes, your autosomes. And males or females can take this test. And if you know somebody who says, oh, I've had my DNA tested, they probably mean they've taken this kind of test because this is the most popular kind. So a little bit about the genes that autosomal DNA testing examines. Some of these genes have specific jobs that make a lot of sense. They make your eyes a particular color. They determine if you're lactose intolerant or not, which most of the world is actually lactose intolerant, and there's a specific gene linked to that. And then there's other genes that scientists have found more commonly or exclusively in certain ethnic groups. And that's how a DNA test will predict what your ethnicity is. And then there's some genes, a lot of our genes actually, that science has not quite yet determined what they do, but if they are rare or unique enough, some of those genes are also sampled in autosomal testing because they can help differentiate between different people. So there are a ton of these genes, which are referred to as data points, that are examined when you take an autosomal DNA test, between 450,000 and 750,000, depending on which company is doing it and how they're doing it. The data points measure areas on your chromosome where unique genes are often found. If you share a lot of these unique genes with someone, you're related. And some of the genes found at these data points are also what is used to make your ethnicity estimate, some of these rare genes. So this included chart shows just kind of a very basic visual of what percentage of DNA you share with a person of a particular relationship. So identical twins are going to share 100% of their DNA, at least 100% of the DNA that's measured in these kinds of tests. Parents and children share 50%, and it goes down from there. Because it goes down, it changes quickly over the generations. After about 6 generations, it's not as good at verifying relationships because after 6 generations, you have so many different ancestors that the contribution of a particular ancestor you might relate to someone else with is small. So if you're interested in testing and learning a little bit more about this, and you haven't yet, a common question is, how do you choose a company to test through? And then there's also often questions of, how do you take the test? I'll go over the first one first, the second one first, because it's pretty basic, and the process is pretty similar no matter which company you test through. So first step would be you order a kit from one of the testing companies. They usually mail it to you. And then depending on what kind of test you've ordered, you follow the directions either way, but it's either spitting into a tube up to a certain line or a certain level, or you swab your cheek. A lot of times there's specific instructions like don't eat or drink anything for half an hour before, or, just follow the directions of whatever test you've ordered. And before you send it back to the company, it's really important that you register your kit online with the testing company, because that's the only way that you're going to be able to see your results when they come in. They also often will give you updates of, okay, we received your kit. So it made it to the lab. Okay, it's processing now. So it gives you updates on your test if you make sure to register it. So once you've registered, mail it off. There's usually pre-packaging included to mail your test off in, and then you will receive your results usually in about 1 to 2 months. There are times where it's slower, there are times where it's faster, but that's the average. So there are a lot of different testing companies, a lot to choose from. There's kind of 5 main ones that I'm going to be discussing. There's other smaller ones out there that, are startup, smaller testing companies at this point. And it's really important to realize that there are multiple testing companies out there, because you may have a relative who's tested at a different company and you won't see them in your match list if you're not at the same company. One way that you can get around this sometimes is some companies will allow you to transfer your data to another company's website to find more matches, which is something I'll talk about in a little bit in the next section, where we compare companies a little bit, and there's some other basic differences we'll talk about. The companies listed here, kind of the 5 main ones, especially for US or European testing, are 23andMe, Living DNA, Family Tree DNA, Ancestry.com, and MyHeritage. So if the types of tests, 3 and 1 means they will give you autosomal DNA data. They will also sometimes tell you a little bit of information about your Y chromosome if you have that, or your mitochondrial DNA. It's not the full data you'd get from taking a Y or a mitochondrial separately, but it's some information. These costs are their kind of base costs, but there are often sales. You can often get these tests on sale around holidays, times like Mother's Day, Black Friday. So watch for those sales if that's something that's important to you. You can see there the biggest companies right now as far as who's tested are 23andMe and Ancestry.com. If you're looking to find a lot of matches, most likely those would be some good ones to test with, though the others are growing and trying to compete and increase their pool as well. And an important column to look at too is which ones allow you to transfer, which you can see it correlates with which companies are the largest are the ones that don't let you transfer your data to somewhere else. So be aware of that. And these numbers are current as of April 2019. They keep going up. Why would you take a DNA test? Some people actually take it for health reasons. 23andMe, that's one of the reasons why they cost more is because they also give you a lot of health data, and that's been one of their big selling points. But other companies are starting to kind of get the message that people are interested in health stuff as well, and they're starting to offer various forms of it. There are other tools out there also that you can take your raw data to and analyze for health things. So you can find out if you're predisposed to cancers, certain allergies, heart problems, which can be really useful, especially if you don't know a lot of your family health history from being told it. So a lot of people are really curious about their ethnicity, especially in the United States. A lot of us have ancestors that are from a variety of places. We may not know very much about how they got here or where they came from, and we're really curious about that. So that's been a big successful selling strategy in the US for people to take a DNA test. They get interested in the ethnicity stuff. So how they come up with these ethnicity estimates, it's based on taking samples from people that are local to an area. So it's usually they take samples from someone whose ancestors are all from, let's say, Poland for the past 3 generations is usually about what they want. And so then they look at all these people they've sampled from Poland and say, okay, these are the things that they have in common. So these might be markers of being Polish. So we'll put that in our database. This is a science that's constantly improving as they get additional data. Scientists and researchers get, more people testing, and they sort of refine what they're looking for. And we'll talk a little bit more in a future webinar about the features of different companies as far as ethnicity goes. So I have a little bit more about this later in this presentation as well, but they're constantly changing. It's getting better, but it still can kind of vary as far as its, accuracy as what it represents of your ancestry. As I said before, they sample your DNA looking for markers unique to certain population. I said results from each sampling run are average. This is true of Ancestry DNA's testing process. Some other companies may not do as much of the averaging thing. They each kind of have their own process, which we'll talk about a little bit, what that generates in terms of results. And one important thing to remember is you don't inherit ethnicity evenly from ancestors beyond your parents. You may not get your great-grandfather's Swedish ancestry because your dad only gave you half of his DNA and he didn't give you that part. And another factor is how pure the sample population was in the first place. That different companies have different reference populations they sample from. They may be looking for different markers, and so you may get slightly different ethnicity results from different companies. So this is just an example of the same person at 2 different companies, MyHeritage, Ancestry.com. These are actually my grandmother's results. She is half Portuguese. Her mother was Portuguese. So MyHeritage really accurately picks that up and says, okay, yeah, you're 50% South European. It puts her as a mix of Iberian and Italian. Whereas Ancestry looks at that and says, okay, you're about 24% Portuguese, about 4% Spanish. MyHeritage shows some Scandinavian, Ancestry doesn't. One thing to know about MyHeritage is they have done a lot more. They have a lot more of people who have tested who are from Europe, and so their results respect European ancestry a little bit differently based on all the work that they've done in Europe. And something different Ancestry does is they're actually trying to do this thing called communities, where they not only say, okay, your ancestors were from this country, but they try to look at who you match in the database, what you have in common in your trees, and be able to predict, okay, you match these people, you have these markers, you probably have specifically Portuguese ancestors who came to Madeira and Hawaii, which is actually true of my grandma. All of these additional communities for her are very true with what her ancestry is. Another interesting thing to do with ethnicity results is to compare different relatives. Like I said, you get half of your DNA from your mom, half from your dad. That doesn't mean your sister or your brother got the exact same half, or you'd be the same exact people. You'd be identical twins. So here's an example of two sisters where they are pretty similar as far as what regions show in their ethnicity, but it's not the same. This is actually me and my sister, and I think it's kind of funny that she shows more Ireland and Scotland than me, because I'm the one that looks Irish and Scottish. She's the one that looks more Portuguese, and yet I got 4% Portugal. She didn't get any of it. Another thing to realize too is populations, even these base populations that they sample of people who have their trees in the area for 3 generations, they're often a mix, because over the past 500 or 1,000 years, not everybody stayed in one place and just married local people. So on Ancestry, my grandma, who's half Portuguese, actually only shows up as 24% Portuguese. And it very well could be because the region of Portugal her ancestors were in had people migrating from other areas. It's also very easy, if populations mix, for a particular ethnicity to wash out over a few generations. So the grandma is 24% Portuguese. Her granddaughter only shows 4% Portuguese. It's possible the granddaughter's child might show 0, even though their great grandma is half Portuguese. It's the randomness of inheritance. Why would you take a DNA test? We talked about the health, we talked about the ethnicity, and here's the part that's really fun and that I enjoy the most, which is family history research reasons, because I'm a family history research person who also loves DNA. Your first reason would be just to confirm the research you've already done. My husband and I have done a lot of research, and our DNA, whether on ourselves or our relatives, has pretty much confirmed everything we already knew about our tree. It's even helped support some theories on lines that we can't quite prove with paperwork yet, because there's a lot of other people out there who've also tested who think they come from the same ancestor as well, and they match us. So that's sort of the first reason. The second reason would be you can connect with relatives who are also interested in the family history because they've taken a test and they're out there trying to find out information about their family. I've been able to receive previously unknown photos or stories from other branches of my family because of DNA connections. I've been able to share things too, which is wonderful because that's something I love to do, is to be able to find someone else in my family who's also interested in our shared ancestors and share what I have with them. The third reason would be the one that you hear about on the news a lot, which is solving a mystery. Solving a brick wall, a line that you can't get past for whatever reason because of a lack of a paper trail or an immigration. There's adoptions, which people who are adopted often are working with very little information on who their biological family is. There's missing person, as in maybe your great uncle disappeared and went west and nobody knows what happened to him. And someday, if you DNA test and one of his descendants DNA test, you might figure out what happened to him. And then there's this term NPE, which if you haven't ran across it, it means non-paternal event. Either someone was adopted by a stepfather, or they were illegitimate, or they were raised by a family member that they thought were their parents, but were actually aunt and uncle or something. So a lot of these kinds of surprises can turn up in DNA research. My husband and I, even though our particular lines turned out to be pretty much what we've expected, we've had a lot of people contact us over the years who are trying to solve a mystery like this, of they don't know their families, they're adopted. And so there's a lot of people out there that are looking for answers like that. So how do you look at a DNA match and know how closely related you are? A lot of times the companies will try to guess for you or give you some ideas of how you might be related, but it all goes back to the numbers, which I'm only going to do a quick rundown of. The companies will either tell you how much percent of DNA you share with someone or how many centimorgans you share with them. Now, this is specifically percentage of the unique DNA they're trying to test, not the DNA that you share with the banana. So centimorgans, they're just a unit of measurement to measure the amount of DNA. They're abbreviated with a little c, a big M. And there are categories of relationships that share similar amounts of DNA. So, for example, a half-sibling and a niece, or a half-sibling and an aunt, they would all share between 18 and 32% of their unique DNA with you, or between 1,300 and 2,300 centimorgans. Sometimes past second to third cousins, you may actually be related to this person, but you won't show up as sharing a detectable percentage with them. Now, there's some caveats to these numbers. If your family is from an endogamous population, a population that intermarried a lot, such as Ashkenazi Jewish, they will share higher amounts than average. Or if your grandfathers were identical twins, you're going to match the descendants of the identical twin more than average. If your mothers were double cousins, which double cousins means you're related to each other on two sides of your family, on your mom's side and your dad's side. Like if two sisters and two brothers got married and both had kids, their kids would be double cousins. There are a lot of tools and charts out there that will help you know, based on how much DNA you share, what the possible relationships are. And so it's also important to, as you're trying to figure these things out, if you can figure out how your other matches relate to each other, this can be really helpful too. And a lot of the testing companies have features that help you to be able to figure out how your matches are related to one another. There are limitations of autosomal DNA. It can't tell you everything. If your relatives haven't tested or they didn't test the same company as you, they aren't going to show up in your matches. And there are some ethnic groups in particular where not a lot of people have tested or tested with a particular company yet. Like I've read stories of people who are adoptees from China and they'll take a DNA test and they don't get a lot of good matches because not a lot of Chinese people have tested yet. Even if you do have good matches, you could send them a message. They might not see it because they might not they might not be interested in answering for whatever reason, or they just might not get on their account regularly. So you're left there waiting and hoping they'll answer you, and they haven't been on their account for a couple of years. Even if you do find some good matches, you communicate, you still have to figure out how you and your match connect. Sometimes it's very easy if you both have good trees, and sometimes it's not. And the further back your research question is, the less likely it is autosomal DNA is going to be helpful. Like I talked about earlier with it being only good back about 6 generations. So who do you have test? It depends on what question you're trying to answer with DNA. Whoever you test has to be related genetically to the family or person you have a question about. So you can't test your grandma and find out anything about your grandpa's family unless they were related. You can test yourself, obviously, if you're the only one that you can get to test and you're curious about your own heritage, have questions about that. If your parents are available to test, that can be helpful because that can help you sort out which matches or which ethnicity comes from your mom's side versus your dad's side. And sometimes that'll help you know too more quickly how you relate to one of your matches. If one of your parents isn't available and you really want to find out about that side, a half sibling or an aunt or uncle could be a good substitute because they'll only represent one side of your family. And another option is the oldest relative in a family line, because you will get better matches and better ethnicity results from their part of the tree if you have your grandma test versus you trying to test to learn about her part of the tree. I was fortunate enough to have all 4 of my grandparents living. I had all of them test. And I get, honestly, when I go and look at my different results I can look at, I go straight to looking at my grandparents, because if there's some new match or new development, I'm going to get more detail on their side of the tree by looking directly at their test results. For an example, my grandma's paternal grandfather is unknown because her dad was born to an unwed mother and nobody knew who the father was. At least nobody's been willing to share that information or is living that knows it. So I had my grandma DNA test, which has gotten me a lot closer to figuring out who her unknown grandpa was than it would be if just I tested. She shares more DNA with that man. She has more matches with his relatives. And so I've been able to get pretty close to figuring out who that man was by looking at her matches. Sometimes you're going to have a situation where you may be interested in approaching a potential biological relative to have them test. You may be adopted and you may be getting close on figuring out who your family is, but you have some possible candidates still that you can only rule out by testing. My grandfather had a first cousin show up as a match, and after doing a little bit of, looking at who her matches were, she was adopted and didn't know where she fit in the family. We were pretty sure it was one of his mom's sisters who was her mother. The potential birth mothers were both deceased because this woman's in her 80s, and any possible half siblings were also deceased. So we had a granddaughter of each sister test, and that gave us the answer as to which woman was this woman in her 80s birth mother. So once you get your results, if you've decided to test, it's a really good idea to get some help from someone who's got experience with interpreting results. We're happy to help here at the BYU Library. A lot of other family history libraries and centers too will have people that have some experience with DNA research, and it's just good to get another set of eyes of somebody to look at what you're looking at. And another good thing to do is to transfer your results to whatever other databases or companies you can, because that will allow you to get more matches. In addition to commercial companies, there's a large site out there called GEDmatch, which will accept transfers from any company where you can compare with other people who are looking to find more matches as well. And it's super important, if you know anything about your family tree, to attach a tree to your DNA results. Lots of people never take this step, and this step can be super helpful to you and to other people out there who are looking to connect with family. Even if you're not on your account very much, even if you pass away, you leaving that tree connected to your DNA results can help someone in the future figure out who their family is. Definitely make sure you take that step and attach a tree. I have a tree that I made that's just very basic because I have an also in-depth research tree, but I have a very basic DNA results family tree that I've attached to myself and my grandparents' test, so someone can quickly look at that and hopefully quickly get the answer of, this might be how I'm related. I've included some helpful links here at the end of just a few websites that have a lot more information if you want to learn more about genetic genealogy and DNA. There's a wiki page that has a lot of good articles. There's an article comparing different autosomal DNA tests if you want to investigate a little more what kind of test you might like to take. There's the Shared Centimorgans project, which goes more into detail of the statistics of how much you share with different degrees of relatives. And then there's sort of a master blog by Kitty Cooper where she links to a lot of other DNA blogs. So you can go to lots of blogs and learn lots of things about DNA. That's all I have for this presentation. So I'm looking forward to seeing what questions people have and being able to answer them.
All right, I am going to switch over to the closing slide. If you have questions, you can go ahead and type those in and I'll read those out and then Sarah can answer those. All right, if there's not any questions, I'll move over to the announcements. I'm going to leave the chat box open if anyone has any questions for Sarah. So our next webinar will be on the 1st with Catherine Grant. That'll be on the Family Tree website and the mobile app, a comparison of those two. It looks like there is a question from Catherine. She said, was there a handout with the last slide links on it? I will post all of those links that Sarah had on her presentation on the post of this recording. So as soon as this video gets posted, which will be no later than Monday, it'll have all those links that Sarah mentioned, so you can have access to that. Following Catherine Grant's webinar next week, we'll have another webinar on the 8th on Thursday. That'll be with James Tanner. He'll be giving a presentation on the history of the development of genealogical DNA. And then on the 15th, we'll have a webinar with Bob Taylor. If you have any comments or questions, you're welcome to email me at fhl_webinars@byu.edu. And if you need to get in contact with Sarah with questions about DNA or interpretation, you're welcome to email me and I can get you in contact with her. The recording of this webinar will be made available on our website, which is fh.lib.byu.edu, or you can catch it on our YouTube channel, our Facebook page, and our Twitter. We are also having that webinar on the 1st will be during the BYU Genealogical Conference. So if you are in town for that conference, please stop by our booth and say hi. And we hope that you can catch that webinar. Thank you so much, and we hope that you have a wonderful weekend.